Hello, this is question 5 on your January 2022 Mechanics to paper. It's a static rigid body question, and I'm going to show you how you can get full marks on it. So you have smooth solid hemisphere is fixed with a flat surface in contact with rough horizontal ground. So this ground is rough, and you have here a hemisphere and a rod on top of it, just is resting in equilibrium on the hemisphere. A is on the ground, so this is on the ground, and they give us the distances. Angle CAO is alpha here, and they ask explain why AO is 13A. So AO is 13A. This is not even a mechanics question, I would say. So you have a line that is tangent to a circle, and you know that the angle between the tangent and the radius in that point is 90 degrees. So this angle here, they don't say, but it's 90 degrees. If it's 90 degrees, we can apply Pythagoras to this. If we apply Pythagoras to 12A, 5A, this AO is 13A. So you can explain that briefly, saying that the rod is tangent to semi or just to the circle, to the semicircle or to the hemisphere, and the angle ACO is 90 degrees. So by Pythagoras, you know that AO, so the hypotenuse AO is going to be the square root of 12A squared plus 5A squared. That means this is 13A. You can say something like that. And this is your first mark, because this little question is just 1 mark. Then we have normal reaction on the rod. I'm here at C has magnitude kW, so they are talking about normal reaction at C, which is perpendicular to not just the rod, by the surface of the hemisphere, and this is kW. They are asking us to show that this K, this constant, is 8/13. So let's go to draw all the other forces that we have. We have the weight in the midpoint, because it's uniform rod. Weight is here, and this distance, so we don't forget, is half of the rod. So this, if the rod is 16A, this is 8A. And then we have a normal reaction here, reaction at A, and we have the friction against the tendency of the motion. So this could slip down, so the friction goes that way. It's what is stopping it of stolen. And we don't have any more forces, because this is smooth, so I don't have any friction here. So if we want to find this K, what we can do, because it's in equilibrium, we can apply forces in any direction it will be 0, and moments about any point will be 0. But we have 2 unknowns here that we don't want to find at this stage. So if we take moments about A, we will get rid out of them, because they won't produce any moment about A. And still we will have W and KW in our equation to find K. So that would be perfect. So that's what we are going to do. We are going to take moments about A, and moments about A will be 0, because it's in equilibrium. So for apply moments, you have 1 mark. If we apply moments about A, we have clockwise is this one, will be the same anti-clockwise, which is this one. So this one clockwise is going to be W times by the distance from A to the line of the force. So this is the line of the force. So we are talking about this distance perpendicular from A to the line of the force. This distance, if we look at this triangle, is going to be 8A cos of alpha. And we know, and I'm going to write here so we have it ready for next time, cos of alpha, if we look at the big triangle, is going to be adjacent 12 divided by hypotenuse 13, because I can cancel the a's. So 12A divided by 13A. And now that you are here, sine of alpha is going to be opposite 5A divided by 13A, 5/13 when I cancel A. Yeah? So this distance here is 8A 12/13. So we have W, and W times the distance, we say is 8A times 12/13 is going to be the anti-clockwise moment, which is the one produced by this one, and the distance from A to the line of the force perpendicular is going to be this 12A, this 12A. So KW 12A, KW 12A. This is another mark for applying moments correctly. And when we simplify and cancel everything that we can, we find that K is 8/13, which is the third mark of this question. So this is B, another 3 marks. Then they say the resultant force acting on the rod at A has magnitude R and acts with an angle theta, and we need to find R in terms of W, so magnitude, and angle theta. So they are talking about a force that is really the combination of these two forces that we have. So these two together, we have a resultant force on A. It will be a combination of the friction and the normal reaction. So that force, it will be something like this. They call it R. So this is R, and the angle is theta. And we need to find that R and that theta. So what we are going to do is to find both components, because with both components we can find the angle and the magnitude easily. One way we can find the components is, and we haven't done it yet, we have applied moments but not sum of forces. Sum of forces we can work vertically and horizontally. So if we work vertically, we have one force pointing up here, one force pointing down here, and one force pointing up here, because here we have, if we resolve forces, this KW has one vertical component pointing up. This angle is going to be alpha, so this one is going to be KW cos of alpha because it's adjacent, and this one here is going to be KW sine of alpha. So vertically we have 1 and 2 up and 1 down. So if we, I'm going to write in the next page because I don't have much space. So if we resolve vertically, we can write something like that. And for resolving vertically, you have 1 mark. We have that the normal reaction pointing up plus the KW, and K, remember, is 8/13. So 8/13, that was cos of alpha. But we can write instead of cos of alpha, the value that was 12/13. So I'm just writing these two forces pointing up. So KW cos of alpha is this, K is 8/13, is going to be the weight pointing down. It's going to be the weight pointing down. And from here, normal reaction is going to be 73W 169. And this is another mark for finding that value for the vertical component. You can call it normal reaction, or you can just say it's the vertical component. It doesn't matter. And then we are going to do the same horizontally. We are going to solve forces horizontally, and we know that the resultant force is going to be 0. This is another mark. So horizontally I have only 2 forces, friction and the sign. So we have friction pointing to the right. Friction pointing to the right is KW. Sorry, I'm seeing here. This is not K, is KW, so this must be W. Here in the second one I have KW, so 8/13W times sine of alpha, that was 5/13. And that's it, yeah? So this is 40W 169, another mark here. So you found another expression for the friction. So that means that my normal, resultant force here, if I use Pythagoras, is going to be this one squared plus this one squared, square root, yeah? So R, the magnitude magnitude of r, that's what they are asking me for, is going to be square root of the horizontal component plus the vertical component. You can call it with friction and normal reaction, or just vertical and horizontal. And this is 1 mark for using Pythagoras. You just substitute the values and you find that then this is going to be root of 41 divided by 13w. And this is 1 mark for this final answer. So 1 for using Pythagoras and 1 for finding the correct answer. And the last thing you have to find is the angle theta, this angle here, angle theta. Tan of this angle is going to be opposite, which is RA, divided by adjacent, which is friction. So we have that tan of theta is going to be opposite, which is the friction, divided by the friction. No, this is not. The opposite is the vertical one, which is RA, and this is the friction. When we substitute, we have 73 over 40. So you have 1 mark for using trigonometry to find this tan. And from here, tan minus 1 of that value gives us this value of theta. And this is another mark. So this part C, and I didn't write part C anywhere, so this is C, is 8 marks. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah. This is all with this question. You don't have any more. Yeah, that's all. Hello. If you like the video, I have a free last minute revision course the week before your exams. The link is in the description below. I'm working with international levels for Edexcel, but if you are an UK student, you will find this very helpful as well because the questions are identical, you just have less topics. I have other courses through the year, they are all in my website and the link is as well in the description below. I would love to help you.